HVAC blower motor electronics. This section will cover the deeper aspects of controlling an automotive blower motor for the HVAC, or air conditioning system. There are three basic ways that the HVAC or air conditioning climate control blower speed can be controlled. These are by the use of a correct limiting resistor, by using a PWM or pulse width modulation controller, and by BLDC or brushless direct current synchronous control. The first control scheme, using resistors to limit the current going to the blower motor, has been used in the past with good basic results. This type of control supported the DC brush electronic motor, applied to the HVAC blowers. In this electric scheme, 3 resistors placed at the airstream reduced the motor current, giving the blower motor the low, 1 and 2 speeds. Then, a high-speed relay was used to provide straight-to-battery connection, at high speed. This particular electrical control scheme, although crude, provided automobiles with a variable speed HVAC system for many years. Then, the second control scheme, the PWM or pulse width modulated electronic control came to the scene, mostly due to a call for better electrical efficiency. Many automobiles in the late 1980s and onward, resorted to the PWM blower speed controller. A pulse width modulated control signal is the basis for this type of control. In a PWM, the upper or lower cycle of a waveform is varied, depending on the need. At the same time, the frequency of the control signal is held steady, although in practice varies slightly. So, by varying the positive or negative half of the cycle, we mean that a steady waveform changes the working part of the square wave cycle, motor vary at speed. This is akin to extending or shortening the pulses going to the motor. In actuality, a PWM control scheme is a type of pulse controller. The third motor control scheme is the BLDC synchronous control. BLDC stands for brushless direct current. In contrast to the other control schemes, BLDC are synchronous motors. The stator magnetic field is controlled by varying the current, and the rotor magnetic field is held steady by permanent magnets. Most importantly, the angle between rotor and stator magnetic fields determines the torque, and the rotor rotation happens at the same time as the stator field. With synchronous motors, the rotor position is measured, in order to achieve synchronization and high performance. Synchronous motors can be used to control position with a great deal of accuracy, but more so, they are very efficient at lower speeds. These are the types of motors and controllers used in hybrid vehicles, and now used as HVAC blower motors. A key advantage of these types of motors is that they have no brushes, eliminating a primary source of wear, maintenance, and ME interference. In addition, they use magnets, giving them higher power density and greater efficiency. BLDC has been relatively more expensive than standard DC brush motors, but now due to higher efficiency HVAC systems, they become more attractive to manufacturers. A feedback loop is needed to control position, speed and, for torque reasons, speed and velocity can be measured with a sensor, or can be calculated by monitoring the back ripple voltages of 3 phases. Then speed is simply the rate of position change ripple humps of over time. This is exactly what we've covered before on our fuel pump operation section for detecting slow and worn-out fuel pumps. While there are many different ways to measure current draw, the most popular method due to cost and reliability is to use a single DC shunt resistor. By simply using the voltage drop across a low-value shunt resistor and programming the ohms logarithm into the speed controller, the current draw is determined. As you can see, there are various ways that the blower motor speed is attained. In 2 of the schemes presented here, deep knowledge of the system is important. Regardless, today, most cars have a form of electronic climate control. Gone are the days of simple resistor blower speed control, so proper training and knowledge are a must.